Salam guys. Okay, learning outcome today. At the end of lesson, students should be able to define the terms empirical and molecular formula, determine empirical molecular formula from mass composition or combustion data. Next one, define for each of the following concentration measurements: molarity, mole fraction, percentage by mass, and the last one, percentage by volume. Alright, and then okay, so chemical formula, we can divide it to two: empirical formula and then molecular formula. So chemical formula, empirical formula is what? The definition for the empirical formula is chemical formula that shows the simplest ratio of all elements in a molecule. Meanwhile, for molecular formula, chemical formula that show the actual number of atoms for each element in a molecule. Alright. So, you can see example for water. Okay, wait. Okay, water. So, water. So, you can see that the empirical formula for water is H2O, and the molecular formula also H2O. So the M value for water is N equal to 1. And then the next example, hydrogen peroxide. Hydrogen peroxide, the empirical formula is HO, and then the molecular formula is H2O2. So you can say that the N value for hydrogen peroxide is N equal to 2. Okay, so next one. Okay. This one. Okay. So molecular formula. The formula is molecular formula equal to N times empirical formula. So the value for the N is equal to 1 or 2 or 3 and so on. So I wanted to calculate the N. So the formula will be N equal to molar mass of the molecular formula. You divide it to molar mass of empirical formula. Okay, and then next one. So 3 types of data to determine the empirical formula. The first one is mass. Second one, the percent and the percentage of composition. And then the last one, combustion data. Alright. So the example number 1, calculating the empirical formula from the mass of constituents. Alright. Given 1.08 gram of aluminium combined chemically with 0.96 gram of oxygen to form an oxide. What is the empirical formula of the oxide? Okay. Where is it? Okay. So the first thing that you all must do is create the table. Consists of element, the mass in gram, amount or the mole, and then simplest ratio. Okay, given in the example or in the question, aluminium, which the mass 1.08, and then oxygen with the mass of 0.96. Alright, from this one, calculate the mole. So the AR for aluminium is 37. You can find it in the table relative of atom mass. So you calculate, you manage to get 0.04 mole of aluminium. And then for the oxygen, the AR for oxygen is 16. So just divide it, 0.96 divided by 16. You manage to get 0.06 mole. And then the simplest ratio. So which one is it? The lower value of mole, this one, right? So 0.04 divided by 0.04, also you will manage to get 1. And then for the oxygen, 0.06 divided by 0.04, you will manage to get 1.5. Alright, so here I cannot round off 1.5 to 2. Okay, so how we wanted to do? So just time to 2, you will manage to get 3. Okay, once you times to 2 here, so for the aluminium also you must time to 2. Alright, so aluminium you will manage to get 2, and for the oxygen you will manage to get 3. Alright, so the empirical formula is Al2O3. Okay, then next one. Okay, a note to remember. Okay, a note to remember. At the final step, for the finding of the simplest ratio, never round off a value close to a whole number in order to get the simplest ratio, but must multiply the value by a factor number, maybe 2, maybe times to 3, maybe times to 4, maybe times to 5, until you get a whole number. However, if the value is very close to whole number, plus minus 0.01, okay, it's allowed to round off and the value. Alright, and then okay, example number 2, calculating the empirical formula from percentage composition by mass. Okay, given here ascorbic acid and vitamin C is composed of 40.92% of carbon, 4.58% of hydrogen, and 54.50% of oxygen by mass. So given the molar mass of ascorbic acid is 176 gram per mole. The mean is empirical formula and also molecular formula. So how is it the step to solve this problem? Alright, so the first thing that you must write down is you all assume that 100% of ascorbic acid has a mass of 100 gram. So you can say that 40.92% is equal to 40.92 gram, and 4.58% is equal to 4.58 gram, and the last one 50.54% is equal to 52.54 gram. Alright, and then okay, so the table, please draw the table. Consists of element carbon, hydrogen, and oxygen. Alright, and then for the part of the mass, just insert the data earlier. Alright, 40.92 gram, 5.58 gram, and 54.50 gram. Alright. From the mass that you managed to get from earlier data, so you convert or you find it the mole. I find it the mole each of the elements. Alright, for the carbon, 40.92 divided by 12.0, yeah, you will manage to get 3.41 mole. 3.41 mole of carbon. And then for the hydrogen 4.58 divided divide to 1.0, you will mean to get 4.58 mole. And then lastly for the oxygen, 54.50 divided by 16.0, yeah, you mean to get 3.41. And then okay, so find it the simplest ratio. Which one is it? The least one, 3.41, right? Alright, so 3.41 divided by 3.41, you will manage to get 1. For carbon, hydrogen, 4.58 divided by 3.41, you will manage to get 1.33. And for the oxygen, also you will manage to get 1. Alright, and then okay, so right now the hydrogen 1.33, so you cannot round off, so you must time to 3. Okay, so once you time to 3, all of the other element, oxygen also you time it to 3, and for the carbon you also time it to 3, and then you will manage to get carbon 3, this one is hydrogen 4 and oxygen 3. So the empirical formula is C3H4O3. Alright, and then next one, okay, the molar mass. Given apa yang diberi earlier, apa yang diberi mana, sorry, apa yang diberi okay, so diberi 176 gram per mole, the molar mass of ascorbic acid, right? Okay, so memang sensitif. Alright. Okay, so firstly you calculate the molar mass of the empirical formula. So from the empirical formula you manage to get C3H4O3, right? Okay, from the empirical formula over there you calculate the molar mass. So carbon 12, so 12 times 3, carbon 12 times 3, hydrogen 1.0 times 4, and for the oxygen 16 times 3. Okay, so you manage to get 88 gram per mole, 88 gram per mole. Okay, and then okay, by using this formula, N equal to mass of molecular formula divided by mass of empirical formula. So given 176 gram, so just divide it to 88 gram from the molar mass of empirical formula, right? So you akan dapat N equal to 2. Alright, and then okay, so you can find it the molecular formula. So N equal to 2, just insert the value for the N equal to 2, And then the empirical formula you already know, C3H4O3. So just time it. So you will manage to get 2 times 3, 6 of carbon, 2 times 4, 8 of hydrogen, and 3 times 2, 6 of oxygen. So your molecular formula will be C6H8O6. Alright. Then, okay. Okay, so done for the empirical formula and also for the molecular formula. So I hope you all understand about the concept or the how is it we want to calculate the empirical formula by using the table, finding the element, uh, the mass, the mole, and the simplest ratio. And do not forget, do not round off the value. Okay, so if you manage to get simplest ratio 1.5, just time to 2 each of the element. All right, and the part of uh, the part of simplest ratio. All right. Okay, so this one solid soluble acceleration I will continue in the next session. Okay guys, so thank you, and we will meet again soon. Okay guys, bye bye.